Hello, my name is Heiko. I'm a PhD student at Max Planck Institute for Software Systems. Today, I want to show you our new tactic language framework, Lassie, for the HOL4 Theorem prover. But before that, I want to answer the question, why do we need a new tactic language framework in the first place? If we want to know why we need another tactic language framework, we have to look at how people learn a new ITP system. And for that, I'm showing you a mock-up example on this slide, where on the left-hand side you see an example mathematical theorem and its equivalent in the HOL4 Theorem prover on the right-hand side. For now, don't bother reading the proof script, because this is just for illustration purposes here. If we look at the theorem statement, which in the mathematical world says if x and y are positive, then the inverse of x is less than or equal to the inverse of y if and only if y is less than or equal to x. If we look at its HOL4 version, we can see that there is a straightforward translation from math to the HOL4 statement. For the HOL4 proof, it is immediately obvious that this is not the case. So, if we think about it, the complexity of these ITP systems inherently lies in the proofs that we have to perform. So why is this the case? If we compare these two proofs, or if we look at how we perform these proofs, there is inherently two steps that one has to perform at the same time when starting off with a pen and paper proof. First, you have to know the steps that were performed in this pen and paper proof, and on the other hand, you have to know the vocabulary for mapping the steps of the proof into the tactics of the ITP system, in this case HOL4. So using an ITP system for a newcomer requires both the detailed knowledge of the involved proof steps, which is just inherent even in math on pen and paper, and the tactics that represent them. So we want to make it as easy as possible to represent these tactics in the ITP system. And for that, our Lassie framework provides the infrastructure to make this step easier for newcomers and expert users alike. And I will show you next how. Suppose we want to define the Lassie tactic, instantiate for all x, p of x, with true. An expert user will define this in HOL4 as the tactic which I'm showing you at the bottom of the slide. And this is only defined by example. There is no need to define a function here. By the use of an extensive semantic parser, this is now automatically generalized into the general tactic instantiate term with term, which gives us a Lassie version of a specialization tactic. And novice and expert users now get a domain-specific tactic language that they can use on top of HOL4. Let us look a bit closer how this would work, for example, in a classroom setting. Suppose you would want to teach HOL4 to a group of students. As an example on this slide, I'm showing Euclid's theorem, which states that the set of prime numbers is infinite. And in HOL4 you would state this as, for any natural number, there exists a number p such that n is smaller than p and p is prime. On the left-hand side of the slide, I'm showing the proof using plain HOL4 tactics, and on the right-hand side, using Lassie's tactics defined by example. We think that these Lassie tactics make it easier for a newcomer to understand the proof steps without having to care about their exact implementation in the HOL4 Theorem prover. So what does the Lassie provide? Lassie is an interactive extensible framework for defining tactics by example. In our paper, we give an implementation of Lassie in the HOL4 Theorem prover, which is available on GitHub and in the process of being integrated with the HOL4 system. In our paper, we show a number of case studies and a HOL4 tutorial, which is also available on GitHub, to show the effectiveness of Lassie. Through the rest of the talk, I want to now quickly jump into the two big points. First, I want to quickly show you how Lassie is used in a proof development, and then go into our HOL4 tutorial quickly. So let's look at how Lassie is used first. Lassie has three main components. The first one being NL_tag, which you have seen in the examples before, which makes Lassie's tactics drop-in replacements for HOL4's plain tactics. Then we have NL_explain, which goes beyond NL_tag's drop-in replacement and helps understand the effect of a Lassie tactic by giving its HOL4 equivalent. And finally, we have def, which allows to extend Lassie with custom tactic descriptions. So this is the tool for the expert users to implement the domain-specific tactic languages. In the interest of time, I want to show you how we used all of these three components to develop a HOL4 tutorial using Lassie. So earlier we saw that using an ITP system requires knowledge of both the proof steps that are involved in a proof and the tactics that represent these proof steps. And the key insight when developing the HOL4 tutorial was that we can decouple learning these proof steps from learning the tactic vocabulary that is necessary for performing them in Lassie. So how do we do that? First, using our def function for extending Lassie with custom descriptions, we have defined a language which we think is more approachable for novice users. Using NL_tag, which acts as the drop-in replacement for HOL4 tactics, we then teach or explain HOL4 proof steps without having to care about the actual underlying HOL4 tactics. And finally, using NL_explain, we can then teach the HOL4 tactics without having to care about the actual proof steps, because they have already been performed before using NL_tag. To conclude, I have shown you Lassie, our interactive and extensible framework for defining tactics by example. In our long talk and in the paper, we go into more details about how we designed Lassie, and we have a number of case studies that show the effectiveness of how Lassie can be used for performing larger proofs. That concludes my talk, and I'll be happy to answer any questions. Thank you.